Respected sir, I am here to present my topic Focused Ion Beam, also known as FIB. It is a technique used particularly in the semiconductor industry, material science, and increasingly in the biological field for site-specific analysis, deposition, and ablation of materials. An FIB setup is a scientific instrument that resembles a scanning electron microscope (SEM). However, while the SEM uses a focused beam of electrons to image the sample in the other chamber, an FIB setup uses a focused beam of ions instead. The construction of a focused ion beam workstation is similar to that of an electron microscope. The probe is fixed on a multi-axis tilt stage located in a high vacuum chamber. The ion column is connected to this chamber. Inside the column, ions are generated, accelerated, and focused. A liquid metal ion source acts as ion source, in most cases gallium or indium ions. It consists of a metal-coated tungsten needle. The scanning of the ion beam over the sample surface is computer-aided. Due to the interaction of the impinging ions with the surface, secondary electrons are generated. Just like in electron microscope, the secondary electrons are detected by means of secondary electron detectors and used to produce an image. Thus, high resolution ion beam induced secondary electron images can be generated. When the ion hits the sample surface, not only the secondary electrons are emitted, but due to their mass, ions are also implanted, defects generated, and sample material removed. This sputter erosion enables local removal of materials by means of focused ion beam in a direct writing mode. Focused ion beam workstations are equipped with gas injection devices which enable gaseous media to be injected close to the sample surface. Etched gases on one hand, for example iodine or chlorine, increases the etch rate for certain materials and avoid redeposition of etched material. On the other hand, adding metallo-organic compounds enable the deposition of ion beam induced conductive material. There are some major advantages for this FIB process. FIB can successfully be utilized to fulfill various purposes, for example fabrication, implantation, and deposition, thus offering unique and potential technique for fabrication of three-dimensional microstructure. It has high flexibility and extremely high features resolution with low lateral scattering. FIB is capable of maskless fabrication of complex micro or nano features on substrate with higher aspect ratio. Any hard metal as well as non-metals can be machined by FIB. Cluster ion beams can be effectively utilized for the surface smoothing utilization at advantage of lateral sputtering. However, in spite of its various advantages, it has few limitations also, which are listed as follows. 1. Cost of the FIB machine is very high compared to other non-traditional machines. Then the substrate or workpiece size is limited for FIB machining. It needs to be carried out in a clean and vacuum environment. Time taken for FIB machining is extremely high compared to the other advanced machining processes. Thank you.